I want to take this example to show you how to calculate the yield to maturity of a bond, which is one of the components of our weighted average cost of capital, or WACC. This is actually from my Finance 605 class, because you should you were supposed to have learned this technique in that class, but in case you have probably taken this class a while ago, so that technique may have slipped your memory already. So this is to be taken as a refresher for that class. Scholitz Corporation issued 15-year bonds 2 years ago at a coupon rate of 8.2%. The bonds make semi-annual payments. So semi-annual is the most common frequency for the coupon payments. If these bonds currently sell for 103% of par value, what is the YTM? That's the yield to maturity. So the first sentence tells us the bond was issued 2 years ago, and when it was issued, the maturity was 15 years. But what matters is not the maturity when the bond was issued. It is actually the remaining maturity. So the remaining maturity after 2 years NAPS will be 13 years. So that's a very important fact just to get to the correct answer for this problem. So I want you to use Excel here to show you how to solve out the YTM. So let me first write down all the input. So yields to maturity, yields will be 13. But remember here, what matters? The frequency of the bond is semi-annual. So we need to convert the number of years to the number of semi-annuals. So semi-annuals, that will be obviously 2 times this equals. I forgot the equal sign. That's very important. Otherwise, Excel will not calculate. It will just show whatever you input. So now it will calculate. So it's obviously 26 semi-annuals. And the coupon rate of 8.2%. So coupon rate, this is 8.2%. But again, what matters is the periodic coupon payment. Since here the coupons are paid semi-annually, so we need to get the semi-annual coupon payment. So we need to divide this by 2 and multiply by the par value. Par value is typically 1,000. If the problem doesn't mention par value, we can assume that to be 1,000. But here, actually, the number doesn't matter because we are solving for the YTM. So, but as a convention, I still assumed the par value is 1,000. So then that means the semi-annual coupon payment will be the coupon rate. Again, this is the annual coupon rate, so we need to divide that by 2 times the par value. So that's our semi-annual coupon payment. And let's continue. If these bonds currently sell for 103% of par value, since the par value is 1000, so we need to multiply this by 103% to get the price of the bond, which is $1,030. So now we have every input which is necessary to calculate the yield to maturity, or YTM. And how do we calculate that? We can use the rate function, rate, which stands for the interest rate, because yield maturity, YTM, is kind of an interest rate. So open parentheses, look at the arguments for this function. The NPER is the number of periods. Here it stands for the number of semi-annuals. So we have this 26 here. And the second argument is the payment. The payment, that's the semi-annual coupon payment. And that's here, 41. And the PV, the third argument, that's the present value. And that here should be the price. Price, because price is traded today, and the fourth argument, so that's the present value, and the fourth argument, FV, that's the future value, and future value here stands for the par value, because that's when the bond becomes due, what will be given back to the investors. So you can just we have other arguments, but most likely you won't need them. So we can just close this parentheses and try to get whatever number. I think the reason I didn't have any output, you can see it's an error term, and that's a very important fact, is because we need to make sure the payment and the present value and the payment, as well as the future value, which is the par value here, they have different operate signs. So that's like a convention to the calculation, either in your financial calculator or Excel. So I need to make sure either the present value is a negative number, hence the payment, and the par value, the future value, are positive numbers, or the other way around. So PV will be a positive number, hence the payment, and the par value will be a negative numbers. But I want to choose the first option, so make the third argument, PV, to be a negative number. So negative, that's a negative price, the 130. So now you can see, the Excel will calculate this yield to the maturity. But as I said, you can, as long as these arguments, they have operate signs, you can get the same answer. So you can also choose the payment to be a negative number. So B5 will be negative, and hence the future value, the par value, will also be negative. So that makes the present value, the price, to be a positive number. So the rule here is the present cash flows, which is the price today, will have a opposite signs to the future cash flows, because either the coupon payment or the par value, they are to be paid in the future, so they need to have opposite signs to the present cash flows. So now you can see, even if I exchanged the signs between the present value and the coupon payment, as well as the future par value payment, that doesn't change the number. So you can see it's still 4%. But what you need to be careful is look at the rounding requirement. enter your answer as a percent rounded to 2 decimal places. So this 4%, it's just a rounded number, and by default, Excel only rounds to the integer. So you need to change the format by right-click. First, put your mouse on this cell and then right-click on it and choose Format Cells. And then this is a percentage. So you can see the decimal places by default is just 0. And we need to change that to be 2 to conform to the rounding requirement for this problem. And what's also very important to this question is the yield to maturity is we should add it's a semi-annual yield to maturity. Why? Because everything so far is in semi-annual terms. So we have semi-annual coupon payment, we have the number of semi-annuals, right? The current price, the par values is just one single cash flow, so that doesn't matter. But everything else is in semi-annual terms. So that also means the interest rate, which is the yield of maturity here, will also be in the semi-annual terms. But what we are interested in is in the annual semi-annual. It is the annual yield to maturity. So that means we need to multiply by 2 to get the annual, change this format, annual YTM. So that's 7.83%. And now let's check the solution. You can see it's the same as what's shown here. So I hope that by using this example, I have shown you how to use Excel to solve out the yield to maturity of a bond. Here it's a semi-annual coupon bond. For the annual coupon bond, generally speaking, the calculation is simpler because you don't have to convert every number into semi-annuals. You can just directly use the numbers from the setup, and you don't have to multiply the semi-annual yield to maturity by 2 to get to the annual yield to maturity, because the yield to maturity calculated from the rate function will be directly in annual terms.